An Introduction to Microscopes, Part 2. The eyepiece, aka ocular, is where we look to see what the famous Van Leeuwenhoek and Hoek saw that made them famous. The eyepiece, as stated earlier, usually has 10x magnification, but occasionally maybe 15x, which increases your magnification. You may purchase these eyepieces separately. The head may allow you to rotate the eyepiece, so the microscope remains stationary, but others can view from different locations. When looking through the eyepiece, keep both eyes open to eliminate eye strain. When you first start, this is very hard to do, but keep trying. In the eyepiece, you will often see a line with a point on the end. This is a pointer for you to point out objects to others. It will spin around when you rotate the eyepiece. Sometimes you will hear students say, "My lens is cracked." It is just the pointer, hopefully. There are some microscopes with two eyepieces, stereo vision relieving most eye strain. These will be used in almost the same way. There is one added step, adjusting the eyepieces to both eyes. First, close your right eye and focus on the object. Second, close the right eye and adjust the left eyepiece by turning it right or left, bringing the object into focus. Third, open both eyes and look at the object. It should be in sharp focus. Are you ready? Not quite yet. First, we need to locate the coarse and fine focus wheels. The large wheel is the coarse focusing control. Use it when first trying to locate an object under the scope. This will make a somewhat sharp image. Then use the smaller wheel, the fine focus wheel, to fine-tune what you're looking at. This may need to be adjusted when sharing a scope with another. Everyone's eyes are not the same. Remember, always start to focus on the slide under 4x, the small objective. Please note, not all microscopes are the same. For instance, the microscope to the left has both focus adjustment knobs on the same wheel, the coarse knob on the wider portion and the fine knob toward the center. Now use it. If you have prepared slides, one purchased from a company, they make great practice microscope slides. For one, they can be clearly seen, and two, they're often colorfully stained. This is not always true when making your own slides. If possible, I would have slides entitled Silverberry Scaly Hair on hand that generally elicit oohs and ahs when first seen. It looks something like a colored firework bursting. Try to discover what exactly silverberry scaly hair is. It is part of the plant in the Elaeaganaceae family and has been stained with usually 3 different colors. Or, if you do not have prepared slides, make your own. Let's look at what we'll need. First, slides. Plastic versus glass. Plastic slides are safer. There are no sharp edges, but scratch, and are many times a one-time use slide. Glass can cause a cut or break if someone is careless, but they give a clear image and can be cleaned and reused many times. Glass gets the edge here. Flat versus concave slides. Flat slides are good as a dry slide or one on which the material must be spread out. Concave slides have a small concave divot ground into the surface, allowing water or another substance to be placed. These are great for live organisms. 2, cover slips. These can also be glass or plastic. Plastic will not cause cuts. They are useless unless misused. They are a one and done. They are fairly cheap to purchase. Glass cover slips can and do break and really can't be cleaned to be reused. Plastic gets the edge here. Eyedroppers and tweezers or dissecting needles, toothpicks work also, are needed to add moisture and to smooth the object when being looked at. Eyedroppers or pipettes may be used, with plastic being preferred for safety reasons. Toothpicks may also be preferred for safety reasons also. Stains. No matter what you use will stain. It will not matter whether it's the object to be viewed or the student's hands or clothing. It will stain. So care must be taken in order to avoid this possible issue. Iodine is easy to find and works with a wide variety of samples. If you're looking at a swimming protist, you may need to use methyl cellulose, which is a chemical that thickens the water in which protists are swimming, thus slowing them down so that they may be more easily observed. This additive goes under several names depending on where it is purchased.